MDM4U 2.1 Data Analysis with Graphs. We're going to learn different types of data as well as graphs that are associated with each. Starting with raw data, unprocessed information collected for a study. So whenever we just gather the information without any interpretation or processing, such as finding measures of central tendency or measures of spread, this is just raw data. Statistics, however, are the gathering, organization, analysis, and presentation of numerical information. So we're going to look at three different types of data. I'm going to start off with discrete data, which countable can be a way to think of discrete versus continuous, which is uncountable. Values are separate. So think of the natural numbers, 1, 2, 3, 4, 5, 6, so on. These numbers don't have any value in between any of them. If it's something like the number of students in the class, we can't select 1.5 students. It's got to be a whole number. And the number of successful trials in an experiment. So if each trial is considered to be success or failure, then we would expect that there would be a whole number answer. Now, that doesn't mean that something like, for example, shoe sizes, which come in half sizes in North America, that is still discrete because between any 2 points, between say size 11 and 11 and a half, no values exist, so they're whole and separate. Now, continuous data, however, is uncountable. A value exists between any two values within a given range. Examples are height, weight, time, and length. So, let's start off with the explanation of height. If I were 185 centimeters and I was still growing and I was going to become 186 centimeters, we do not instantaneously go from 185 centimeters to 186 centimeters. We take on every height in between in that interval. And there's an infinite number of possibilities between any two points in a continuous data set. So, for example, between 185 centimeters and 186 centimeters, there's the midpoint between those 2 points, and that belongs to the set. But also the midpoint between 185 and 185.5, which would be 185.25. So you can always imagine that every 2 points that are not equal in a set have a value in between them. And actually, there's an infinite number of values between any of those two numbers in a set. And that can be said for weight, time, and length. Next, categorical data. Labels are assigned to the outcome instead of numerical data. For example, color, type, or country. So it doesn't have order necessarily. So we're going to discuss tables first. There's frequency tables, which can be used in a study. A tally is used to count observations, and the frequency is how often it occurs. So if we were to look at the sum of two die being rolled, if we were to complete an experiment live and we wanted to record the results, we don't want to write down the numbers. There's an advantage to keeping a tally, which is an ongoing total of your observations. And that allows you to record as you go, as opposed to writing a number and then erasing it and rewriting it. So every fifth number in a tally is written as a cross, a strike through of these four. So this is 5 plus 4 to make 9. Cumulative frequency, a running total of the frequency of a variable beginning with the smallest value. So these first 3 columns are identical to our previous example. The cumulative frequency, however, is an ongoing running total. So first off we have 4, then for the next unit we have 2, so all together we have 6. Then the next one we have 3, so 3 plus 6 is 9. And then 9 plus 9 is 18, a running total. I think of it like a shopping cart, and I keep adding things into it, getting a cumulative total. Next, a bar graph and a histogram. On the surface, They look very similar, agreed, but there's a key difference. A bar graph has exact values represented at each bar, or categories are shown on the x-axis. So, for this right here, we have categorical data. But with a histogram, values in a set can be grouped into intervals to better display the distribution of data. So, a couple of things that we need to unpack. First of all, distribution of data is a term that refers to the spread of the information here. In this histogram, notice that the values are in intervals, 5 to 10, 10 to 15, and so on. So we don't have the precision or the precise values of a set. If we had a table, we would lose a little bit of precision because if it's between, say, for example, 15 and 20, the total number of elements in the set that belong to that interval just increase the frequency. It doesn't matter whether it's 19 or 16, it doesn't specify that. So the way that we can determine the total number of data points would be adding the frequency of each of these intervals, where we have 2, 5, 10, 7, 3, 2. Altogether, that's 29, I believe. So this is something to note. The x-axis is travel time to school in minutes. And if we are using time as our variable, that is a continuous variable, because even between, let's say, 15 minutes and 20 seconds and 15 minutes and 21 seconds, there's still an infinite number of possible times that someone could arrive. So the likelihood of a particular outcome, an instantaneous length of time. So what I'm saying is being at precisely the same instance. That is very unlikely to ever happen again. And therefore, it wouldn't be wise to represent that as a frequency graph, because the likelihood of each outcome would not be more than 1 in a frequency diagram like this. But with a histogram, by selecting a range, that's going to have more continuous values put into this range. So yes, we could do this for discrete values as well if we wanted to look at the distribution, but this is commonly used for data that is in a continuous interval. Lastly, relative frequency. Relative frequency is expressed as a percent out of the total. So the type of graph which is used to compare parts of the whole is a pie graph or circle graph. And what you can do is look at, for each part, meaning each outcome out of the total number of outcomes, what is that as a fraction, multiply it by 100%, and that will give you the percentage value for that particular group. And then what you can do is multiply that by 360 degrees if you were drawing this by hand. Now, we will be learning how to graph using Microsoft Excel or spreadsheet software. So that being said, relative frequency is used often in pie graphs, and it's helpful to compare parts of the group. Good luck.